class, we are going to study about application specific concept. Okay, we have previously seen what is application specific. Okay, so we are going to take an example and we are going to see how the example suits this. So the example we are selecting today is the washing machine. Okay, so now let's see how this washing machine suits this. So washing machine is application specific because your washing machine can only do washing. It cannot do any other function. Okay, so that's why we call washing machine as application specific. Okay, now let us take the general block diagram of embedded system and let us match this with the washing machine. Okay, the first component we are going to see is the sensors. Okay, so what will a sensor do? A sensor will convert physical quantity to electrical quantity. So your sensor will convert physical quantity to electrical quantity. So now in your washing machine, what are the sensors used? We will use generally or probably we will use only two sensors. The first one is the level sensor and the second one is the temperature sensor. So what is the level sensor for? Okay, so as soon as you load the clothes into your washing machine, what happens? Water flows into your washing machine. Okay, based on the quantity of clothes, the amount of water varies. So the level of water is decided by the level sensor. Okay, the second is your temperature sensor. The water which is flown inside your machine has to be in a particular temperature. Okay, so in certain machines you have options to wash in hot water, you have options to wash in cold water, and you have options where you can select a moderate level of temperature. So all this is maintained by your temperature sensor. Okay, so two sensors we are using. One is the level sensor, the other one is the temperature sensor. So we are done with the first block. So what will your sensor do? Your sensor will convert the physical quantity to electrical quantity. Okay, so in your temperature sensor, the temperature is converted to electrical quantity. In your level sensor, the level is converted into the electrical quantity. Okay, so now the electrical quantity which you have got is analog in nature. Okay, whereas the CPU which you are using is digital. So what are we doing? We are doing an analog to digital conversion. Fine. Once this analog to digital conversion is done, it comes to your CPU. So your CPU is the control unit. This does all the processing. Okay, so your CPU will have a small memory. Okay, and in that memory you will be having your software. Okay, your software will be written in that memory. So that software is a program which is going to control all the functions of your washing machine. Okay, now here you have an additional feature called FPGA, which is field programmable gate array, or ACIC, application specific integrated circuit, or your non-digital hardware. Okay, so if your application is very specific, you have a separate IC for that, and that is called as FPGA or ASIC. FPGA, once more I will repeat, it is field programmable gate array. And what is ASIC? Application specific integrated circuit. Okay, so if your application is specific, you can make a small IC for that, and that is called as ACIC. Okay, so we are done with the first three blocks. Fine. Now your fourth block is your digital to analog converter. So once your CPU does all the processing, fine, the digital quantity is again converted to the analog quantity. Fine. Now the control goes to your actuator. So what will your sensor do? Your sensor will convert physical quantity to electrical quantity. What will your actuator do? Your actuator will do just the opposite of your sensor. So your actuator converts electrical quantity back to the physical quantity, that is the mechanical action. Okay, so the electrical quantity is converted into the mechanical action. Okay, so now let us see the various actuators you have in your washing machine. Okay, the first one is your inlet control valve. Okay, so what is this valve used for? Okay, as soon as you load your clothes inside, what happens? The water comes through this inlet pipe. Okay, so the water enters the machine through this inlet pipe. Okay, the level of water that has to come inside is controlled by the inlet control valve. Okay, so the inlet control valve, based on the quantity of clothes, water is loaded into the machine and closed by this inlet control valve. Okay, the second one is your tub. Okay, you can also call this as the drum. Fine. Basically, you have two tubs. One is the inner tub and the other one is the outer tub. Okay, the inner tub will have small holes in it. Okay, whereas the outer tub will not have any holes. Okay, fine. So two tubs you have. One is the inner tub and the outer tub. With this picture you can see the inner tub will have small holes in it, whereas the outer tub is a solid fixed one, okay, which is present just outside your inner tub. Okay, the third actuator is your agitator. Fine. Your agitator is also called as the rotating disc. Your agitator is also called as the rotating disc, and you can see this in the picture. Okay, so which is your agitator? The center part which is present here is called as the agitator. So this is also called as the rotating disc. So what is the function of your agitator? This agitator is connected to a motor. So you call this agitator as the motorized agitator. Okay, so this motor, you have the option to control the speed of the motor. You have the option to control the speed of your motor based on the action. Okay, so if you're doing washing, the speed will be moderate. But if you're doing spinning, the speed will be very high because it has to take out all the water from the clothes. So during spinning, the motor speed will be very high. Okay, so now what is the function of this agitator? This agitator rotates continuously. It produces rotating currents. Okay, so what happens? The clothes also rotate and the washing is performed here in this agitator. Okay, fine. Now the fourth actuator is your water pump. Okay, so water pump is used for two things. One is for pumping water into the washing machine, and the second one is for draining the water out of your machine. The first one is for pumping in, and the second one for draining out. So these are the various actuators. Okay, I will repeat all this once more. The first one is the inlet control valve, which is used to control the water which is entering in based on the quantity of clothes. Second is the tub. You have two types of tub. One is the inner tub and the outer tub. You would have seen this. The inner tub has small holes on it, whereas the outer tub is a solid one with no holes. The third is the agitator, which is called also as the rotating disc. This is called as motorized agitator because this agitator is connected to a motor and the speed of the motor is varied based on the action performed by your washing machine. The fourth is your water pump. So water pump will do two actions. One is pumping in water and the second one is draining the water out. Okay, so in your block diagram, we have covered sensors, analog to digital converter, CPU, digital to analog converter, and actuators. Okay, now you have the human interface port. So what is this human interface port? How is the system going to interact with human beings? That is called as the human interface. Okay, so here we have the input-output interface. So in your washing machine, how are you going to give the input? You have a keypad. Okay, nowadays this comes as touch screen. Okay, with this keypad, you give input to your washing machine. So what are the various inputs you have? You have options for start. You have options for light, medium, heavy. So if your clothes are light, you select light. If it is medium, you select medium. And if you have a very large quantity of clothes, you select heavy. Okay, the next is the operation. Fine. So what are the three operations possible? Basically, you can do wash, okay? you can do rinse, and you can do spin. These are the three basic operations. In addition to this, you have one more operation called the stir. Okay, so now we come to the spin later. I'll finish this off. Okay, so children, if you look into the keypad, there are also options for setting the time. You can set the time as 30 minutes, 1 hour, or 2 hours. Yes, all this is done by a timer. So you have a hardware timer with which you can set your time. So this part gives you the facility to give input to your washing machine. Okay, now how do you see the output? There is a display, and this display is called as the LED display. So using this display, you see what is happening to your washing machine. Okay, you would have seen if something is wrong with your washing machine, you would get a symbol E here, which means there is an error. Okay, so whatever is happening to the washing machine is told to you by the output device, which is your LED display. Okay, hope everything is clear to you. So now, usually in washing machines, we have two models. One is the top load and the other one is your front load. You would have seen pictures of two. Okay, in the top load, you load your clothes on top. In the front load, you load your clothes in the front. Okay, there is a small difference in the operation between the top load and front load, and we will see that one by one. Okay, before that, what are the three important phases in your washing machine? First is wash. The second is, come on, I have told this to you before. First is wash, second is rinse, and the third one is spin. So what happens during these phases? During the first phase, your clothes are washed thoroughly. All the dirt from your clothes are removed. Yes, and in the second phase, your clothes are rinsed. That is, it is rinsed in water so that all the detergent and all the unwanted things that are present in the clothes comes away. Then this is done using clean water. And the last phase is your spin. So what happens during the spin phase? During the spin phase, all the water from the clothes are removed completely so that you are at ease of drying your clothes. Okay, all the water is taken out completely in the spinning phase. So during the spinning phase, the motor will rotate at high speed because all the water has to be squeezed out. Okay, so your motor will rotate at high speed. Now let us see how a top load washing machine works. So this is the diagram of your top load washing machine. So I think you can quickly identify all the parts. We have the inner drum, we have the outer drum. The inner drum is with holes. You have the agitator. The agitator is controlled to the motor. Okay, you have a lid for closing. Okay, then you have the input output display together with the control unit. Then you have your inlet valve. Okay, then you have the outlet pipe through which water goes out. You call that as the drain hose. Water comes in through this, water goes out through this. Okay, now let us see how it works. So now the first thing you will do is you will load the clothes into the washing machine. So in a top load washing machine, you will open the top and you load the clothes on top and then you will close it. Okay, now you connect it to the power supply. Then what you do, you open the tray, you put the detergent on the tray and you close the tray. Fine. Now you turn on the supply. So immediately what happens? The water inlet valve opens and the water comes into the washing machine. Okay, the amount of water that should come inside the washing machine depends on the quantity of clothes. So I have already mentioned you have the level sensor which will work with the water inlet valve and it will determine the amount of water that should come inside the washing machine. Okay, now you have water inside the washing machine. So first you put your clothes. Okay, now you have water in the washing machine. Fine. How this water comes? Through the inlet valve. Fine. Now, immediately after this, your agitator starts to work. So what will your agitator do? Your agitator, like I told you, is connected to the motor. So this is a motorized agitator. Your agitator will move back and forth. Okay? Your agitator will move back and forth, and it will pull all the clothes bottom to top and top to bottom. Okay, it will pull all the clothes bottom to top and top to bottom. So why is this done? The water together with the detergent and all this rubbing action will remove all the dirt away from the clothes. Okay, so with this your washing is done. Okay, as soon as your washing is done, all the water, that is the dirty water, through the holes which are present in the inner drum, are drained away, and it comes out through the drain house. Okay, drain hose. All the water comes out. Now you get fresh water. Now all the water will be drained out. Okay, now what happens? You get fresh water. Okay, so now what is this fresh water for? This fresh water is for the rinsing purpose. So what will happen in rinsing? Again, the same action will happen, but all the detergent, all the soap that you have added will be removed from your clothes, and your clothes will become very clean. Okay, so once all this is done, the last phase is your spinning phase. So what happens in your spinning phase? In your spinning phase, the motor which is connected to your agitator moves very fast. Okay, so all the water which is present in your clothes will be drained out, and your clothes will be easy for you to dry it. Okay, so these are the various actions that takes place in your washing machine. Okay, so you have to remember, during spinning what happens is several hundreds of rotations will happen. You call that as RPM, rotations per minute. Several hundreds of rotations will happen so that the water goes out. Okay, so this is how your top load washing machine works. So I have an animation which tells you how this works. You can look into this animation. So first you put your clothes, water comes in, okay? It starts washing, all the clothes go up and down, and the clothes become very clean, okay? Now with the spinning phase, the motors are rotating very fast, and all the water from the clothes come away, okay? So this animation will clearly tell you what are the operations I have told you before. Okay, for the exam point of view, you can use this diagram for drawing, because all those diagrams are difficult to draw. You can use this diagram to draw. Okay, so you have your inner drum, you have your outer drum, you have your level sensor, you have your temperature sensor. Okay, you have the water inlet pipe, you have the outlet pipe, you have your keyboard, you have your LED display. So you can use this diagram for explaining the working during your exam. So this is your front load washing machine. Okay, the front load washing machine is same as your top load washing machine, except that there are small changes in the working. So in your front load washing machine, okay, you load the clothes in the front and you close the lid with the door which is present as shown like this. Okay, so here what happens is the clothes are tumbled and plunged into water over and over again. Instead of agitator going up and down, the clothes are tumbled and plunged into water over and over again. So this is how the clothes are washed. Except this, the phases are all different. First you will wash, then you will rinse, then you will spin. All the other things are same, except that the way the agitator works alone is different. Okay? You don't have a separate agitator. Your clothes are tumbled and plunged into water over and over again, and that is how your machine works. So whenever they ask you application specific embedded system, you can take this washing machine as example. First, you can draw the general block diagram. You can explain all the components in the general block. See, first you can draw the general block diagram. You can explain all the components used in the washing machine. Then you can explain the two loads, that is the top load and the front load. Then you can explain the three phases. Then you can explain the working of this with a block diagram. Okay, hope it is clear. If you have any doubts, you can ask me. I'll clear it off. Thank you.